Freeform templates. You can customize your own policy or edit and push your own CLI-based configuration if needed to different elements. There are at least two options deploying your own templates. As already discussed, if you feel the soul of a programmer, you can modify or write your own Python script to push the CLI command of choice to the network device. This is interesting as, for example, you can pop up a Windows and call the end user to fill up a different field with their parameters of choice, right? Or if you want to keep the traditional NXOS network configuration approach, you can edit a freeform template to save and push your well-known CLI command, the same CLI that you used to use from the console port. The goal of the freeform is to quickly provide a maximum of flexibility for the end user to configure almost everything that is not natively embedded with DCNM. So that way you synchronize your CLI-based intent with the central management platform. And DCNM is therefore aware of your configuration that it can monitor. The freeform policy can be associated to one or multiple switches. It can be used for a device, for an interface, for a link, for a protocol, network, etc. Then you save and deploy your own freeform template, and consequently DCNM pushes your own configuration to one or multiple switches, synchronizing the DCNM database with your configuration that you can monitor for compliancy and to back up your configuration if you wish, etc. Let's visualize this with a demo. The scenario here shows how to configure Hsrp using a CLI approach with the freeform template. You first select the device of choice. You create a new freeform template for these configurations. You save and deploy. You can always view, change the CLI or delete the freeform template on the fly. The action will be taken as soon as you save and deploy. Let's have a look. From the main page, select the Fabric Builder space and jump into the Fabric 1 where you wish to deploy a freeform template. Select Leaf 1, right-click to call the View Edit Policy knob. A pop-up window appears with all policy templates associated to this particular node. Select the plus button to create a new policy for that device. From the list of available policy templates, select the switch_freeform template. A new window appears. As you can notice in the drawing, we have a server attached to the VPC with the VLAN 33. Back to the template windows, give a descriptions, fill up the freeform config area with your CLI commands. You can use copy and paste from a script or from a running NXOS prompt. As you can see, this is a traditional Hsrp configuration used for that VPC device with the IP address 33.251 and the VIP.254 for the interface VLAN 33. Do a save and close the windows. You will deploy later. Repeat the same action for the other VPC peer device, except now for the second VPC device, the IP address is different. (33.252) and the VIP address is the same for the interface VLAN 33. Do a save and close the windows. Now from the Fabric topology, you can save and deploy using the global button that review the pending configurations for all nodes that belong to this Fabric 1. As you can see, Leaf 1 and Leaf 2 are out of sync. You can preview the configuration that is pending for each device and retrieve the Hsrp configuration. When ready, you can deploy. This action will take few seconds to deploy the configuration toward both Leaf nodes. From the host connected to the VLAN 33, you can now ping the VIP 33.254. Next sections cover the config compliance. Thank you for watching.